My name is George, and I will be your guide through this Rubik's Cube rigging tutorial presented by cmiVFX, a SideFX training partner. Let me first of all show you what we will be going after. I will begin by installing the digital asset we will be creating, so let me just go to my File menu, and here I will click on Install Digital Asset Library, and I will go to the folder where I saved this asset, and I'll select it. It's Rubik's Cube.otl. So I'll hit Accept. And here you can see that this OTL file contains this Rubik's Cube digital asset. So I'll click on Accept here. You can see nothing has changed in my viewport, but if I go to my network view here and I hit Tab, you can see that a new entry here is added. It's called Digital Assets. I will show you later how we change that. And I'll click on Rubik's Cube here to create a Rubik's Cube node. We will be getting into all of that in more details later, but for now, let me show you what this digital asset does. As you can see here in my viewport, when I created this node, it created a Rubik's Cube here. And if I have this node selected, in the parameter editor here, you can see some custom interface I built to be able to manipulate this cube. At first, when one is asked to create a Rubik's Cube rig, it seems simple. But once the real work begins, problems begin to arise. One of the reasons is that with the Rubik's Cube, we will have multiple rotations around multiple axes, which, as you may know it or not, at some point will break. So let me just play a little with those buttons here to show you what they do. Let me just minimize my network view, and here let me for example take the top face and I'll hit +90, and in the viewport, let me just go a little bit closer, you can see that the top face of my cube rotated 90 degrees. If I hit -90, it will get back to where it was before. I can use +180, -180, or even we can use a custom value. So if I enter here, for example, 63 degrees, and I hit on custom, you can see that my top face rotated 63 degrees. And let me just get back to where it was. So I'll hit -63 here, and I'll hit custom, and it gets back to where it was before. And as you can see here, I have buttons for each and every face and every row of my cube. So here we have the right, the left, the top, bottom, front, back, etc. And also we have the mid-Z, mid-Y. Let me show you what that is. So if I put here 63, for example, and I hit custom, you can see that this middle row rotated here, and those mid-Z, mid-Y, and mid-X are for those middle rows on Z, Y, and X. So let me just put -63 here again, hit custom, and now let me play a little bit with my cube. So let me do +90 for the right, -90 for the left, +90 or -90 for the top, +180 for the bottom, -90 for the front, etc., etc. So I'll just play with those buttons here. And here in the viewport, you can see the effect of the rotations I'm doing. Now that my cube is messed up, I want to get it back to the original state. So I will go a little bit up, and I'll click on this reset button here. And as you can see, it gets back to the point where we began messing with it. An important point to mention here is that our Rubik's is not only a cube that is playable, because the goal at the end is normally to create a Rubik's or a similar animation. So not only we want to rotate our small cubes, but we want to be able to animate them. That's why you find here this Set Key button. So let us try it and see what it does. My timeline is at frame 1, so let me hit Set Key, and you can see that the key appeared here as a green tick. So I will go to the frame 24, I will rotate my top face +90, then I will hit Set Key again. I will go to frame 48, I will rotate my left +180, I will set a key, 72, bottom +90, set a key, 96, I will go and I will rotate the mid X +180, and I will set a key, etc., etc. Here in the timeline we have a bunch of keys, so if I hit play, you can see my Rubik's is animating correctly. And not only that, because we will also add the ability to animate the cube as a whole. So if now I hit T on my keyboard, and let me go to my frame 1, and I will just go here to the transform tab, and I will set a key on its translate. Then I will go to frame, let us say 72 or 73, and I will take my cube, I will translate it a little, I will take it here, I will set a key again, and then I will get back to my frame 1, and I will hit R on my keyboard. I will set a key for my rotations. Then I will go to, let us say, frame 48. I will rotate my cube a little. I will set another key. I'll go to frame 96. I'll rotate it a little more. I will set another key. And then one last time, let me go back to my frame 1. I will set a key on its scale, and I will go to frame 48, let us say. I will change its scale to, let us say, something like that. I'll hit a key another time to frame 96, and I'll rescale it back up, and I will set my last key. So now if I get back to my frame 1 and I scrub through the timeline, you can see that my cube is animating, the faces are animating correctly, and the whole cube is also animating, so it's rotating, scaling, translating, and everything is working without breaking. One thing I should add here before ending this introduction is that not only I can animate the faces of my cube in the rest position and then animate the cube, in fact we can animate the faces of our cube whatever the position it is in. So let me go back a little. Here I will go, let us say, to frame 120, and I'll go to my Rubik's Cube tab here, and I will, let us say, rotate the left side plus 180, and I will hit set key, and then I will go to my frame 144, for example, and I will do a rotation of minus 180 on my top, and I will set a key, and here you can see if I scrub through my timeline, the rotations are working correctly, even if I animated the faces of my cube while it is in this translated, rotated, and scaled position. Let me hit this back up and up again so we can have some space here, and then I will right click on my node. It's still not showing in my window, so let me just minimize my menu on my shelf, and then I will right click again on my node and I'll click on this type properties entry here, and inside this dialog that will appear, that we will see later in detail, under the scripts tab we can see the script we will be creating along this tutorial to have the result I just showed you. And here under the parameters tab, we will be creating all the buttons and the interface we will be using to rotate and set the keys, etc. for our Rubik's. So let me hit cancel for now. Other things we will be doing include using custom geometry instead of the default cubes you can see here. So if I go and I take this down, and here I go to the custom geometry tab, let me just create, let us say, a sphere. So I'll just create a sphere in the center and I will make its scale 0.5. Since my small cubes have their edges as 1 and my sphere has a radius of 1 by default, so I set its scale to 0.5 to have a diameter of 1. So now if I go back to my Rubik's Cube node and I go to the custom geometry tab, this cube here in the corner is my front right top cube. So I will search front right top, it's the first one, so I will hit on this button here and I will make it point to the sphere, and when I hit accept, you can see that this cube here is replaced by the sphere. So we will also do that, and if we still have time, we will also add some proceduralism to the default cubes. In this tutorial we will see many methods and techniques and we will learn a lot of stuff, so let us jump to the next part and begin working on our Rubik's Cube rig. Let us begin by creating our geometry. Here we have to make an important decision before proceeding. So we have to decide whether to create our geometry in sub-level or in object level. And what I mean by sub-level is having only one geometry node and putting all of our geometry inside. And by object level, I mean having one geometry node for each one of our small cubes. You should know here that sub-nodes do not contain a separate object transform. Even if you use a transform node, for example, which can be confusing, but such nodes directly transform the point positions. And one other thing is that if we create our geometry on sub-level, there will be more code involved because we need to compensate for the object level transforms. For these reasons and more, I decided that it's better if we go the object level way and create one geometry node for each one of our small cubes. So to begin, we should create 26 small cubes. To do that, we can do it manually by creating the geometry nodes one by one and then translating the boxes inside to match the corresponding positions. But since it's a repetitive task, let us do it using Python. So let us open up a Python shell. You can open it from the window menu here by clicking on Python shell or by clicking Alt-P. So I'll click on Python shell. Let us do the creation of one box manually to see the steps involved, and then we will replicate that in Python. So let me go to my network editor here. I'll hit tab and I'll go to geometry and I'll create a geometry node. So the first step is creating the geometry node. Then I will go inside and I will delete the file node which comes by default. So I'll delete this node. The second step is deleting this node. The third step is I'll hit tab and I will type box. So now we have 3 steps: create the geometry node, delete the default file node, and then create the box node. And then the last step is to change the center parameter here to position our box where we want it to be. So let us say, for example, 1, 1, 1. So this is it. Those are the 4 steps involved in creating the small cubes for our Rubik. So let us now replicate that in Python. Let me go up 1 level. I will delete this and I will go to my Python shell. Okay, here I will introduce you to some commands, and then we will combine those commands to create our cubes. So the first command I want to show you is the create node. So to create a node in Houdini, I will use the who module, and first of all I will tell it where I want this node created. So let me, for example, type my node creation place equals, and here I will type who.node, and for this node function I will specify the path where I want my node created. So I will open a parenthesis and I will type for now /obj. Then I'll close the apostrophe and I'll close my parentheses, and then I'll hit enter. And as you can see, I do not have any feedback. So just to see what does my node creation place now evaluate to, I'll just hit print and I'll type my node creation place. And now you can see that my node creation place now contains my object's context, which you can see here in this menu. So now my node creation place contains this object level here, and if I create any node inside it, it will be created on this level here. So let us now take my node creation place and create a node inside it. So I will type my node creation place dot, and here I will call the create node function. So I will type create node, and as you type you can see the list of available function appear. So I'll just use the create node. I typed enter by mistake, so let me just hit the up arrow key and it will take me back here. I will open the parentheses and then I will specify the node I will be creating, which in this case will be a geometry node. So I will open an apostrophe and I will type jo, close the apostrophe and close the parentheses, and then hit enter. And here in my network editor, now you can see that a jo node appeared and it's called jo1. And in the Python shell, you can see that I had some feedback here saying that we had created a node called obj jo1. One another interesting thing you can do here is that you are not obliged to use an intermediate variable. So you can directly type, let me just do it here, I will just directly type who.node and I will specify obj, and then directly I will do a create node without passing with my node creation place variable, etc. So I will just type who.node obj.create node and I will specify geo here, and then I will hit enter. And you can see here that now I have 2 nodes, geo1 and geo2, without using an intermediate variable in my Python shell. So this is a faster way to do things if you do not need to use your variable for other things in the script. Now that you know how to create a node in Python, let me introduce you to the for loop. Let me just type here for I in range, and I will, let us say, choose 0 to 10. At the end of the for line we have to type a colon, don't forget that, and then I will hit enter. And here let me just type any command just to show you the error and show you how we fix that. So I will just type print I and hit enter. And this is because in Python the indentation is very important. So now to fix this error, I will just click on my up arrow 2 times. I'll hit enter again for this for loop, and then I will hit tab just to create an indentation, and then I will type print I. And then I'll click enter 2 times, and here you can see that I'm printing numbers from 0 through 9. So the first number is included, the last number is excluded. Just pay attention to that because it may lead you to errors later. So as you can see, the for loop using the range function is fairly simple. You have only to say for and declare a variable, in my case it's I, and say in range 0, 10, which gives you a number between the first number and the last number. You can also do many more things with this for loop and with the range function. I won't go into details about that for now because this form will suffice for what we need to do, and the for loop is not the goal of this tutorial. So now if you want to use that to create small cubes, we only have to do for I in range 27. Don't forget the colon. Hit enter. Tab who.node /obj dot create node jo, and hit enter, and then enter one more time. And you can see that it created 26 nodes for us. Here you can see jo28 because we had those 2 nodes before. So we created 26 and we had 2, so here you can see 28. And also you can see here at the beginning that we began from jo3 instead of jo1 because we had those 2 nodes here before calling this function. So as you can see, it's fairly simple to use the for loop and the create node function to create multiple nodes at one shot in Python. Let me delete all these nodes, and then I will show you how we can delete the default file node which comes inside the default geometry node. So let me just here create another geometry node. So I will type who.node /obj dot create node, and I will do a geo node. I've got an error because I had the slash inverted, so I'll go a little bit back and I'll type it like this, and here you can see my node is created, and if we go inside we have this file node that comes by default. Now I want to delete this node. One way to do that is to loop through all the children of the jo1 node and delete them. So to do that we will use a for loop. It's fairly simple. We will do for, and here we will use another form of the for loop because prior to issuing this command we do not know the number of children of the jo1 node. In this case we know because we saw it, but if we are automating some script we do not know for sure the number of children of some node. So we will use another form which will iterate through all the children of some node without us knowing the number of those children. To do that we can just type for child in my node dot children. But since we didn't declare my node here, I forgot to put a space here, so since we didn't declare my node, this command will fail. So if I do this now and I hit enter and I type print child, this command will fail because my node is not declared. So to declare my node, as I told you earlier, we have to type my node equals who.node /object dot create node and jo. So as you can see I've got an error because I typed minus instead of equals. So I'll hit my arrow up key and I'll type equals, and now it works. So now I can issue this for loop. So I'll hit my up arrow a few times, and here I have my node declared, so now it should work. I hit enter and I will type print child. Same error I showed you before because of the indentation, so I'll hit my up arrow 2 times and I'll hit it 2 more times. I'll hit tab here and I'll hit enter and then enter again, and now you can see that I have file 1, which is the child node of my jo2 node, because now we are working on the jo2 node because we created a second one. So here is my file 1, and now if I want to delete this node, instead of using the print function I will use the destroy function. So I will go and do a for loop again. I will hit tab and I will do child dot destroy. And now when we issue this command you can see that this node disappeared from here and I deleted all the child nodes of the jo2 node. Now don't forget also that at any time you can use the who.node function to point to some node that exists already. So if I go up one level here and I go inside my jo1 node, the file 1 exists here. So if we want to delete that, we have only to declare this jo1 node as a variable. So if I go here, I will do my jo1, for example, equals who.node, and here I will do /obj, and I will do another slash, and I will choose jo1. I'll close the apostrophe, I'll close the parentheses, and I'll click enter. And now my jo1 points to my jo1 node. So if I want to delete all the childs of this jo1 node, all I have to do is issue this command one more time, but this time I will replace my node with my jo1. I'll hit enter, and I will hit tab, and I'll do child dot destroy, and I'll hit enter again, and here you go, the child nodes of jo1 node are destroyed. So now you know how to create a node, how to use the for loop, how to delete all the children of some node. What's left to do is for you to know how to change some parameters on some node, and then we can combine all that together to be able to create all the cubes for our Rubik's Cube. So to change the parameters of some node, let me just go up one level and let us just take a simple example, and let us say change the translate parameter on this geo1 node. Since we have it in the variable my geo1, it should be easy to do. So let me just do my geo1 dot parm. This parm function will let me specify the parameter I want to change. So if we go here under translate, I'll just leave my mouse a little bit over this parameter here, and you can see parameters tx, ty, and tz. And so for this parm function, we will give tx, ty, or tz to be able to change the translate for our geo1. So here for my parm function, I'll just open the parentheses, I will type tx, and this way I'm telling it I want to change the tx parameter of my geo1 node. Then I will hit dot again, and I'll use the set function, and I'll give it some value, let us say 5. And before I click enter, just take a look at the translates. They are 0, 0, 0, and now when I click enter, you can see that the translate x, tx, became 5. So this way you can change the translate x, translate y, translate z, or any other parameter you want on some node. You may ask, what if I want to change the 3 values at one time? So to change the 3 translate values at one shot, for example, you have to use tuples. And to do that, let me just declare a tuple. So I will say my geo1 underscore translate, for example, equals my geo1 dot parm tuple. So I will use the parm tuple function, and for this parm tuple function I will give it t for translate, because my translate, as you know, are tx, ty, and tz, so the common part between those 3 is the t. So for my parm tuple I will give t, and then I will click enter, and now inside my geo1 trans I have the parm tuple for the translate of my geo1. So now if I want to change the translates all at once, I have to type my geo1 underscore trans, and I will have to issue a set command on this tuple. So I will do dot set, I'll open the parentheses, and then I will give them 3 values, let us say 4, 6, 8, and then I will close the parentheses 2 times, and I'll click enter, and now you can see that 468 appeared here in the translate parameter of my geo1 node. So those are 2 ways with which you can change the parameters of some node. There are many other functions and ways also, but those are the 2 we are interested in for now. Now that you know all these commands, let us combine them all together to create our Rubik's Cube. Let me begin by deleting those 2 nodes here. I'll take this a little bit to the side, so it's easier to see what's happening in the viewport, and at the same time be able to see what's happening in the network editor. And here I will start with a for loop. So I will type for I in range. 2 important things I should mention here is that I said earlier that we need 26 small cubes, and that's true, but while writing the Python it's easier if we create 27 small cubes. You will see why just in a minute. And instead of creating all our 27 cubes inside one for loop, we will use 3 for loops, and this way positioning our small cubes will be a lot easier. And this is why, because I'm using 3 nested for loops, each looping 3 times, I'm obliged to create 27 small cubes instead of 26, but this will make things a lot easier to position my small cubes. So for my first for loop, I will say for I in range -1, 2, I will open a colon. Just remember that this range function will give us -1, 0, and 1, so it will do 3 iterations. I will hit enter, I will hit tab, I will do my second for loop for j in range, and I will use the same -1, 2, colon, I will hit 2 times tab, and for k in range, also -1, 2, and colon, and I will hit enter. And now I will hit 3 times tab, and I'll begin creating my nodes. So I will do my geo node equals who.node / obj dot create node, and I will use geo. I'll hit enter. There's a typo here, so let me just correct that. I'll just do this, then this, then this, and then here I just put the slash outside of the apostrophe. So I will just invert that and I'll hit enter. And here we have this line creating our nodes, and it's doing it 27 times. So now we have 27 cubes created. I will hit 3 times tab again, and here, as we said before, we will delete the childs of the node created. So we will do another loop, and we will type for child in my JO node, and I'm using my JO node because, as you can see, I declared it here. So I'm using here my JO node dot children, and don't forget the colon. Hit enter. This time hit 4 times tab, and then here I will issue the command child dot destroy, as we did before. I will hit enter again. Now we will hit tabs 3 times because the following commands, we do not need them to be inside this for loop. Instead, we want them to be inside this for loop. So I will point my cursor here, and now I will type my box equal, I'm creating the box inside my geometry node, so I will type my box equal my JO node dot create node, and I will type box here, and this way we create a box inside every one of our geometry nodes. And then I will hit tab 3 times also, and then here we will set the translate parameter for our small cubes, so we can use any one of the 2 methods, either the direct method or the tuple method, but the tuple method is shorter, so let me use it. I will just put my box underscore t equal my box dot parm tuple, and I will specify the translation, and here I will just set the values of the translation of my small cubes. So I will just do my box underscore t dot set, and here I will specify I, J, and K. And now you can see why I used this form of nested for loops here, because it's a lot easier to position my boxes this way. Here you can see I'm using directly the I, J, and K, because here they are varying between -1 and 1. So the values I'm using here will directly position my small cubes as I want them to be. And this is why I used this 3 nested for loops. So now all I have to do is to hit enter 2 times, and you will see in my viewport and in my network editor my Rubik's Cube created. So I will hit enter 1 time and a second time, and here you can see that in my viewport the Rubik's Cube was constructed, and in my network editor let me just hit L, and here you can see the 27 cubes we have just created, and inside each one you can see that we created a box node, and for each box node you can see that the translation parameters are now varying between -1 and 1. So if you take JO1, you can see here -1, -1, -1, and if you take, for example, the 27, you can see that it's 1, 1, 1, and all the others are varying in between. So this is it basically for the creation of our basic geometry. Next we will be creating some nulls to be able to detect the position of each cube and then to be able to act on them. So let us move on to the next part. Now we will begin taking our first steps into rigging our cube. The first trick you should be aware of is that the small cubes will be switching faces. And what I want to say by that is that every small cube, and after being rotated, will find itself in another face. So if at the beginning it was at the top face, after 2 rotations involving it, it may find itself in the left face, for example. This is why a very important step is to detect which small cubes we want to have moving with the face's rotation. So detecting the position of our small cubes is critical, and we can do that in multiple ways. A very simple one would be by parenting a null to each one of our cubes, and then whenever we need to know the position, we will read the position of that null. Now you may ask, why don't we read directly the position of our small cube geometry node? It's because, let me just minimize my Python shell here and select one of our small cubes and hit T. I'll get a little bit closer, and here you can see that its pivot is at the origin, having 0, 0, 0, and this is because we will be rotating our small cubes around the origin. This is why we left the translation at the object level as 0 and we translated our box nodes inside instead. So let us create a null node at the object level for each one of our small cubes and parent it to it. We will take advantage of the code we wrote earlier, and we will just modify it a little bit. So I will get back my Python shell, And first of all, let me declare a variable to index our nulls. You will see why in a bit. So I will just type index equals 1. And now we will gonna use the same for loops we used earlier to create our geonodes. So I will use my up arrow to get to them. I will use the first for loop, then the second one, and the third one. And here I will get to my create node function, and instead of creating a geonode, I will just create a null node. And I will change the name of the variable from my geonode to my null node. And then after that, I will position my null nodes the same way we positioned our small cubes. So let me use my positioning code. I will go a little bit up, and here I will create a tuple for my null node. So instead of my box, I will type here null node, and I will rename the variable from my bot underscore t to my null underscore t. And then I will hit enter, and I will continue the positioning with the my null underscore t dot set ijk. And this way I positioned my nulls the same way I positioned the small boxes, so this way I will get a null in the center of each small box. And at the end, the only thing left to do is to parent each null to its corresponding geonode. It's a new code, so let me just type it manually. I'll go here, and I will declare a new variable called parent, and I will put in it who.node / obj, and here you can see the list of all my geonodes. I will just type geo, and because I want to choose for each null its corresponding geonode, so I'll just close my apostrophe here, and I'll use plus, and I'll add the index we created earlier. But since the index is a number, so I'll use the str function to transform this number into a string. So I'll just type str, and I give it the index, and I'll close my parentheses. I'll hit enter, and the last thing we have to do is the parenting itself. So let me just type here my null node dot set first input, and I will make its parent the variable I have created called parent. Let me just make sure all the syntax is correct. It's good to go, and the last thing I have to do is to increment my index, because otherwise all the nulls will be parented to my geo1. So let me hit enter, and I'll increment my index. I'll do just plus equals 1, and I will hit enter 2 times. You can see the nulls are created and they are parented correctly. To be able to see them correctly, let me hit L in my network editor. And here you can see now that I've created a null object for each one of my geonodes, and it's parented to it. Let me just minimize my Python shell here so we can see the nulls in the viewport. And if I rotate, you can see that each null is positioned inside one of my small cubes. So now the nulls are created, they are positioned correctly, and next I will just create some simple materials and assign them to our faces, just to be able to differentiate between our faces when we do the rotations. Let me just hide all these nulls. So I'll do it here. I'll just select all these nodes and I'll make them invisible. As I said before, we are going to assign some materials to our faces to be able to differentiate between them. So let me begin by creating a shop network. I will go to my network editor, and here I will hit tab, and I'll create a shop network. I'll just rename it to materials, and then I will go to my material palette, and here I will create a basic surface material to begin, so we can see it here, and I'll leave it as white. Then here I will rename it to white, and I will copy and paste it 6 times. So those are 5, and then I'm gonna need one more, and here it is. Let me just change the colors of those. So I'll make this, let's say red. I'll make it red here. Then for the second one, I'll make it blue. I'll change its color to blue. This one I'm gonna make it green. And then I'll make this yellow. And the last one, I'm gonna make it orange. And now we've got 6 different colors that we are gonna assign to our small cubes. So let me go up one level, and here let me search for my geo1 to begin with, and I will go inside, and here I will hit tab and I'll create a material node. Let me hide all the other objects. And here we are going to assign one color to each face of our small cube. So I'll just hit this plus button here 5 times to obtain 6 tabs, and then I will begin assigning one material per primitive. So I'll begin with the primitive 0, and I'll give it the color blue. The primitive 1, I'll give it the color green. Then the primitive 2, I'll give it orange. Primitive 3, I'll give it red. Primitive 4, I'll give it white. The primitive 6, I'm gonna give it yellow. So here we have all the colors assigned to our cube. Let me just show all the other cubes. Now you may ask, why did I assign 6 colors to a cube where I only can see 3 primitives? Well, because what we are going to do next is we are going to copy this material to all the geonodes we have. So we are going to assign this material to all the small cubes we have here. And for now, I will not worry about the faces facing inwards. So I will just copy this material to all of my small cubes. To do that, I'm going to use Python. So I will open up my Python shell. And here, first of all, let me declare a variable containing the material we are going to copy. So I'll just call it material. I'll call it mat equals who.node, and here I will make it point to /obj/geo1, and then I will choose material 1. So now mat contains my material node, and then I will iterate through all of my small cubes using a for loop. So I'll do for I in range, and here instead of beginning with the number 1, I'll begin with the number 2 since the material 1 exists for my geo1. So I will do 228. Remember that 28 won't be included, so the last number will be 27. And then here I will declare the destination where I want to be pasting this material. So I'll call it dest, and I will make it equals who.node, and then I will make it point also to /obj/geo. And then here, since we are going to iterate through all of our geonodes, so I'll close my apostrophe here. I'll do plus stri. Then I will hit enter, and this way now we have our material and we have our destination, and all is left to do is copy this material to this destination. So what I will do is who.copy nodes to. Here we have to open square brackets, and inside we have to specify our material. So I will just type mat, I will close my square brackets, then I will type comma, and I will type my destination, which is dest. Then I will close my parenthesis, and I'll click 2 times on enter. And here you can see that my material was copied to all of my nodes, and here is the last one copied. You can see here it changed from geo1 to geo27. And now if you search inside all of your nodes, you can see that material 1 now exists in all of our geonodes. So here's it, and if we look in our viewport, now we can see that all the faces of our cube are colored. And as I said before, we are not going to worry about the faces facing inwards for now. So this is it for the basic scene creation. Next we will begin taking our first steps into digital assets. If you want to continue from here, open the file called Rubik's Cube 2.hip from the project files folder. So in this section, we are going to begin creating our digital asset. To begin doing that, the first step will be, let me maximize this, I will select all of my nodes, including my materials shopnet here, so I'll select them, and I will hit Shift-C on my keyboard. This way, Houdini will group all of my nodes inside one subnet node. Let me get closer to it. Here you can see it created this subnet node for me, and inside it, it put all of the nodes we had selected. So let me go up a level here. I'll just rename this subnet node. I'll call it Rubik's Cube, and then I will use this subnet to create my digital asset. It's fairly simple. All I have to do is just to right click on this node, and here you can see create digital asset. I'll just click on it, and then a window will pop up, and here it will ask me for some information I have to fill and then I will save my OTL file which will contain this digital asset. So here for the operator name, I'll just call it Rubik's Cube, and for the operator label, I'll just put an apostrophe here. The minimum and maximum inputs, I will leave them as 0 because I don't need them, and then I will specify an OTL file I want to save this digital asset to. So I'll click on this button here, and I'll go to my OTLs folder in my project files folder, and here I will name it Rubik's Cube, and I'll hit accept. And then when I hit this accept button here, this digital asset, this Rubik's Cube digital asset, will be saved inside this Rubik's Cube.otl file. So I'll hit accept, and now my digital asset is created, and this type properties window popped up, and here's where I can make a lot of modifications to my digital asset. So here, for example, you can see the label of my digital asset. You can see that I can choose an icon. You can see that I can change the minimum inputs and maximum inputs, etc., and other parameters. You can use this parameters tab to add or subtract spare parameters. We'll use it later, so we'll see it in more detail. Here you can write some help information about your digital asset. Here you can create handles for your digital asset and then link them to some parameters in it. In this script tab here, here's where you can write code to include it in your digital asset, and this is where we will gonna create our code for the rotation and the keying of our Rubik's Cube. And as you can see in this event handler menu, you can write expressions, you can put a Python module, you can execute a code whenever the digital asset is created or whenever it's loaded, etc. In our case, we are going to use this Python module since we are going to create our code in Python. And if you want to, you can, for example, instead of saving the Rubik's Cube inside the digital asset, you can, since we created all the Rubik's Cube with Python code, you can just use uncreated, and here under edit as, instead of HScript, you can use Python, and you can paste the code we used to create our Rubik's Cube here. So this way you can delete all the nodes inside our digital asset, and then whenever an instance of this digital asset is created, this code will recreate the Rubik's Cube for you from scratch. I won't do it for now, but just know that you can do it. I'll just delete this uncreated. And here under tools, there are also many important things like the context tab, for example. Like here, you can choose where your digital asset will be available. For example, in the network pane, I will make it available under the objects context, and under the viewer pane, it's under the objects context by default. And here you can find a parameter called tab submenu path, where you can specify the name of the folder containing your digital asset in the tab menu. And you have also the ability to attach hotkeys, to write help, etc. And you can as well add selectors, you can also add extra files and other things. But the two tabs we are most interested in this tutorial are the scripts tab, because here we will be creating our code, and our parameters tab, because here we will be creating the interface to be able to use this code. So let me hit accept here, and now you can see that all the inputs here disappeared from my subnet, and now I have a digital asset created. And if I hit tab, you can see here the digital asset entry, and here we have Rubik's Cube. So now I can create another instance and another instance as much as I want. And if I minimize this window, here let me hit T on my keyboard, you can see that now we have many Rubik's Cubes. Let me hit L here, and you can see that now I have many Rubik's Cubes in my viewport. Let us next begin creating our first script inside our digital asset. Here I'm beginning with an empty file in which I want to install the digital asset library we had created earlier. So I will go to File, Install Digital Asset Library, and then I will click on this button here, and I will make it point to the OTL file, to this Rubik's Cube OTL file we saved earlier. So I'll select it, and I will hit accept 2 times. Then I'll click Tab in my network editor, and under Digital Assets, I can see this Rubik's Cube entry here. So I'll create an instance of it, and we can see the Rubik's Cube appeared in our viewport. Now what I want to do here is a very simple and basic example to show you how the system works. I want to create a function inside my digital asset, and then I want to call it, let us say for example, when I click on a button. For this, let me maximize this window here, and let me take this a little bit up so you can see the menu. I'll right click on it, and here you can see this type properties entry, the one on the bottom here, and here you can see the type properties window I talked about earlier. So as I said, here we are interested in this parameters tab and this scripts tab mostly. And also, as I said before, here in this scripts tab, you can create scripts inside your digital asset. And since we are going to create Python scripts, let me go to the event handler here and change it from custom script to Python module. And then on the right side here, we can begin creating some Python code. The code we will be creating is a very simple code just to show you the concept. In fact, we are going to create a simple function to rotate our first small cube, which is called Geo1. So to create a Python function here, I will begin with the word def, and then I will call my function rotate. I will open close parentheses, because for now I do not want to give it any parameters, and then I will put a colon, I'll hit enter and tab. Then since we want to rotate a specific node, I will put here who.node, and I will make it point to obj, then to the instance of the digital asset we had created, which is Rubik's Cube 1, and then slash Geo1. So we are going to be rotating this Geo1, let us say 90 degrees around the x-axis. So I will close the parenthesis here and I'll type dot parm. Then I want to tell it that I want to change the rotation around the x. So I will put here rx, and then I'm going to change the value of this rx. So I'm going to use the set function. So I will do dot set, and I'll put 90 in here. So this is it for this line of code. Let me make sure that this line of code works correctly. So I will just minimize my network editor, and then I will open up a Python shell. And here, let me just copy this line, paste it here, and execute it. Before doing that, I want to mention here that now we are going to get an error, and then I will tell you why. Let me hit enter, and here you can see that we have a permission error. You can see it here. The problem is that whenever you install a digital asset, it's locked by default, so you have to unlock it. I will remaximize this window here, and I will right click on my digital asset instance, and I will click on allow editing of contents. Then I will minimize it, and I will get back my Python shell. So here I will hit the up arrow, and I will execute this code one more time. We didn't get the error this time, and if we rotate a little bit around our cube, we can see that this small cube here, which is called Geo1, rotated 90 degrees. And you can see it flickering here. So it rotated 90 degrees. And if we go inside our digital asset and we go to our Geo1, let me show you that, you can see here that the rotate is now 90 degrees. So let us reset that back to 0. And let me go up again and get back my type properties window. So now we are sure that this code works correctly. Let us hit apply. Then the next question we should be asking is, when do we want to execute this code? So let us, for example, link this code to a button, so whenever this button is clicked, this function is executed. To do that, I will go to my parameters tab here, and then I will drag a button from the left side to the existing parameters column here. And then for this button, I will rename it to rotate, for example. I will change its label to rotate. And then we have this callback script slot here, which allows us to execute some code whenever this button is clicked. So inside this, we are going to call our rotate function. To do that, it's very simple. First of all, we are going to tell it where does this function exist. So we are going to tell it who.node, and we are going to make it point to obj Rubik's Cube 1. Let me just copy this from here so we don't get a typo. I'll just paste it here. So now we've got our digital asset instance, and then we are going to tell it that the function exists inside this digital asset. So we are going to type here .hda module to tell it that the function exists in an HDA module, and then I will open close my parentheses. And then the last thing I want to do is I want to call this specific function, which is, if you look here, is called rotate. So let me just copy this, and here I will add at the end dot rotate. So this is it for what we want to do, and don't forget that this line of code here is in Python, so the script language shouldn't be HScript, but instead it should be Python. Now I will hit apply, and if I minimize this, you can see here the rotate button appeared on the instance of my digital asset, and now if I click rotate, you can see that my small cube here, my Geo1, rotated 90 degrees. So everything is working correctly. Now what if I wanted to rename this node? Let us say I do not want it to be Rubik's Cube 1, instead I want it to be Rubik's Cube DD. And now if I click on this rotate button, you can see that I've got an error. So why is that happening? It's happening for two reasons. The first reason is that if I go to my type properties, you can see here that we specified Rubik's Cube 1. So whenever we change the name, this line of code here will not work anymore. And adding to that in our scripts tab here, we specified also Rubik's Cube 1. So whenever we change the name of this digital asset instance, the script won't work anymore and the code on the button won't work anymore. And this is also valid whenever we create multiple instances of the same digital asset, because every instance will have its own name, so the code won't work anymore. How do we solve this problem? Well, there is a way with which you can get the reference to your digital asset instance. Instead of using an absolute path with the who.node function, you can just type instead kwrgs, open square bracket, apostrophe, type node, and then close the apostrophe and the square bracket one more time. And now if I hit apply and I minimize this, it won't work also because, as we said in the script, there's also an absolute path. So how do we solve that? In fact, what we have to do is let us go to the scripts tab here, and instead of using obj Rubik's Cube 1, we have to use the path to the specific instance we are working on. So how do we do that? Let us just delete those from here, and then let us pass it as a parameter to our rotate function. I will call it Rubik's instance, and then here I will gonna type Rubik's instance dot path plus Geo1. Now what's left to do is to give to this rotate function the Rubik's instance we are working on when we call it. So I will go to the parameters tab again, and here instead of calling it as rotate without any parameters, we are going to pass the instance of our digital asset to it. And now we know that the instance of our digital asset can be given with this kwrgs. So I will copy this and I will pass it to our rotate function. So I will paste it here and I will hit apply, and now it should work. So I'll hit L, I'll select this, and if I click on rotate here, we can see that the small cube is rotating and everything is working correctly, even though I changed the name. So let me hit Ctrl Z, and here I will call it something, and I will click rotate and it will still work. And if I create another instance now, so I'll create Rubik's Cube, you can see that the rotate button appeared here also. And let me just translate it a little so you can see it. And I click rotate, you can see that it didn't work. It's because the asset is locked. So I'll right click and I'll allow editing of content, and then I'll click rotate, and you can see that now it's working. So in this part we learned how to add a function to our digital asset, how to add a button, and then how to call this function with this button, and how to solve the problem of the multiple instances and of the names changing. Let us next use all what we've learned here to begin coding the rig of our Rubik's. Let us begin getting deeper into our code. Here I installed the digital asset as we got it in the last part, and I just unlocked it. So here if I click on this rotate button, you can see here it's rotating my Geo1. So let me hit Ctrl Z. Let me open up my type properties window. Here it is, and I'll go to the scripts tab, and here I'll begin adding little by little to my code to get it a little bit more complex. The first thing I want to do here is I want to make my rotations incremental. Here, if you look at what we've done before, you see that for this set function here, we gave a constant value, which is 90. So whenever we click on our button, the value will get to 90, and we cannot change it anymore using this button, of course. So now we want to get this value incremental. So every time we click on this button, it will add 90 degrees. So let us get going. The first thing we want to do is we want to read the current value. But here, instead of reading the rotation values, I want to read the whole transformation matrix. And while we move on with our code, you will gonna discover that using the transformation matrix will get us a more robust code especially that, as I said in the beginning of this tutorial, getting multiple rotations around multiple axes will get us into problems. So using the whole transformation matrix will simplify our code and will make it more robust. So instead of reading simple rotation values, I will read the whole transformation matrix. So let me begin by getting our Geo1 node into a variable. So let me just delete those here, and getting my who.node Rubik's instance.path plus Geo1 into a variable. I will call this variable small cube. So I'll put small cube equals who.node Rubik's instance.path slash Geo1. Then I'm gonna read the transformation matrix of this small cube. To do that, I will just type xform equals small cube dot world transform. And this way, now I've got the world transform of my small cube into the variable called xform. Now that I've got my transformation matrix into a variable, I want to do the 90 degrees rotation, and then I want to set back the transformation matrix of my small cube. To do a 90 degrees rotation using the world transform, Houdini has some special function for that, and we will see that in a bit. So let me just hit enter, and here I will declare a variable called rotation, and then I will make it equal to who.hmath.build rotate. So we are going to use this build rotate function to do our 90 degrees rotation. And now I'm assuming that we are going to do a 90 degrees rotation around the x-axis. So I'll open a parenthesis and I'll do 90, 0, 0. So I'm saying I want to do 90 degrees around the x-axis and 0 around the y and 0 around the z. Now that I've got a rotation value, I want to multiply that by the xform I've got earlier. So let me just do result equals xform multiplied by my rotation. This is it. So this result here is basically this xform matrix rotated 90 degrees around the x-axis. So now I will get back those rotation values from this result matrix and I will give them back to my Geo1. So let me get those rotations back. I'll do that doing rotation values equals result dot extract rotates. So I'm going to use this function. And now that I've got the rotation values, I want to get them back to my small cube, which is Geo1. So I will do small cube dot parm rx dot set rotation values 0. So I'm gonna get the x value to the rx, and then I'm gonna copy this line, I'm gonna paste it here, then I'm gonna paste it here, and I will change this x to y, this x to z, and then here I'll change this 0 to 1 and this 0 to 2. This is it. As you can see, here we put our node into a variable, then we read its transform matrix, its world transform matrix, then we applied a rotation to this matrix and we've got it into the result matrix, then we extracted the rotations from this result matrix and we got them back to our small cube rotations. Now let me hit apply and let us try our button. So let us click on rotate, and here we see our cube did a 90 degrees rotation, and we click another time and we see that it did a second rotation. Let me just hide all the other cubes, maybe it's easier to see this way. So I'll just select all those cubes, I will leave only my Geo1, and I will hide all those nodes. So now we can see only our Geo1, and here if I click on rotate, we can see it rotating each time 90 degrees around our x-axis. So our code is working correctly, and now we are rotating incrementally around our x-axis. Now that we've got our incremental rotation working, let us in the next step begin writing some conditions to be able to tell which small cubes belong to which faces, and then we are gonna do the rotation around the different axes, not only around the x-axis, and we are gonna go a little deeper into the code. Before proceeding, I want to show you a few things. The first one is that, as you may have noticed it or not, whenever the node is locked, its name is blue, like I have here. But if I unlock it, let me just switch those two panes here, just so you can see the whole menu easily. and I'll right click on it and allow editing of contents. And now you can see that its name turned red. Just so you know, when the digital asset is locked, its name is blue, and whenever it's unlocked, its name becomes red. For the second thing, I will use an example to show you that. Let me go inside my Rubik's Cube node, and here you can see that the names of my nodes are still generic. Let me rename them to something relevant, like small cube instead of JO and small cube pause instead of null. We will use Python like we've done before, but before getting into the code, let me just get closer to my cube here. I'll hit W, and then if in my network editor I select my 14th JO here, you can see that it's the center of my cube. I won't be renaming that in my code because I want to treat it differently later. So I will exclude it from my naming code. Let me get my Python shell, and here I will begin with a for loop to loop through all of my nodes. I will do I in range 128, and then I will create two variables, one for my geo nodes and one for my null nodes. The first one will be small cube node equals who.node /obj /Rubik's Cube 1 /geo, and then plus stri. Then the second variable will be small cube pause for position equals who.node /obj /Rubik's 1 /null plus stri. Now, as I said, I will be excluding the 14th from the renaming code, so I will hit tab, and here I will do a condition saying if I not equal 14, we continue, and to prevent having a gap between the 13th and the 15th number, if I is greater than 13, I will decrement it by 1 unit. So I will say if I is greater than 13, decrement it by 1 unit. Then we will rename our nodes. This is the only new function we are seeing in this new code here. So I will do small cube node dot, and I will use the function set name to change the name. So I'll do set name, and I will give it the new name, which will be small cube underscore, and then I will add to it stri. Then for the second one, it will be small cube pause dot set name, and I will do the same. Here I will call it small cube pause, and I will add stri. This should do it. So let me hit enter 2 times, and here our code is working. If you get to our network editor here, you can see that all of my nodes are now renamed correctly, small cube 11, small cube position 11, etc., except for our 14th one. Let me get it a little bit down here, and I will rename it center and center pause. Now, the thing I wanted to show you is that, let me go up 1 level here, and let me create a second instance of this Rubik's Cube node. So I will hit tab, and I will create a second instance. Now, if I get into this node here, you can see that all the node names are still JO and null. What's the problem? In fact, the problem and the thing you should know is that whenever you change anything inside the digital asset, not inside the type properties window, you have to save it explicitly. So if I go now up 1 level and I right click on my node here and I click on save operator type, and now let me delete this node, and I will do tab, and I'll create a new asset of my Rubik's Cube, and now if I dive inside, you can see that the nodes are renamed correctly. So remember that anytime if you change something inside your digital asset, not using the type properties window, you have to save the digital asset explicitly using the save type operator you can find here. Let us get back to our rig code. Last thing we've done was the incremental rotate. Let me just right click here and go to type properties, and here we can see our script. Now it won't work, of course, because we changed the names of the nodes. All you have to do to make it work again is change this geo1 here to small cube 1. So I'll do just small cube 1 and I will hit apply. And now if I click on my rotate button, let me just minimize my Python shell and get here. And now if I click on my rotate button, you can see that the code is working. I'll just delete this instance so you can see it. You can see this empty area here, and that's saying that my cube rotated. We can also go inside our node to check it out. So if I go to my small cube 1, you can see that here it's minus 270 degrees, so I'll just set it to 0. The next step will be iterating over all of our small cubes to be able to rotate them. And then after that, we will set some conditions to begin differentiating between the different faces. Let us just make all of our cubes rotate at once for now before beginning setting the conditions. So let me get back my type properties window, and here I will just begin with a simple for loop. This time we will gonna do for I in range 1 through 27, since now the center cube is taken out, so I only have 26 cubes. And then I'll just increment the indentation here, so I'll use this button. And I will change the name here from small cube 1 to small cube plus stri. I will hit apply and I will try my code. So let me minimize this, and then I will hit on the rotate button. Now you can see that all of my cube is rotating around the x-axis, and since we didn't create a reset button yet, let me just go inside here and reset all of the rotations. So I'll just select all these nodes, deselect the materials, I'll hit on P, and then I will set all the rotations back to 0. Let me minimize this. Next, let us create a few test buttons, one to rotate all of our cubes around X, the other around Y, and the third around Z. So let me get back my type properties again, and here under my parameters, I'll just duplicate this button here, so I'll just select it and click 2 times on B, and now I have rotate, rotate, and rotate. The first one I'm gonna call it rotate X, then the second one I'm gonna call it rotate Y, and the third one I'm gonna call it rotate Z. Then we have to change their codes, so I will go up here, and you can see here that we don't have an entry yet to specify an axis, so I'll just add it here and then add it into my code. I will put comma and then open apostrophe, type X, and close apostrophe. Then I will do the same for the rotate Y and rotate Z, but I will give them Y and Z instead of X. So comma, apostrophe, Y, and for the Z also, I will do comma, apostrophe Z. Then I will go to my script to account for that. So under my script, here I will add comma, and I will type axis. Next, if you look at our code, you can see directly that the rotation around the x-axis is happening here in this rotation line. So I have to set some conditions to choose the rotation corresponding to the axis I'm using. So I will hit enter here, and then I will do an if condition saying if axis equals x, we are gonna rotate around the x. So we are gonna set the rotation to 90, 0, 0. I will hit tab for the rotation to include it in this if, and I will add a colon here. Then I will copy those 2 lines and I will paste them 2 times here. Then for this one I will put Y and I will give it 0, 90, 0, and for the last one I will type Z and I will give it 0, 0, and then 90. And then here I won't forget to use else if, and for this one also I will use else if. Now let me hit apply to see if that code works. So I'll hit apply here, and then I'll use my rotate button. Let me go up 1 level, and I will use one of my buttons. Let us say rotate Y. I've got an error here, and that's because, let me just get my type properties window back. And here if we look at our parameters, we can see that Houdini added automatically to our functions _x at the end. So I'll just delete these _x here, and for the other 2 also I will do the same for the rotate Z also, and then I will hit apply, and then I will try again to rotate my cubes. So let me click on rotate Y, it's working, rotate X, it's also working, and rotate Z, and it's also working. So now we've got our rotations working around the 3 axes. Let me just hit Ctrl Z 3 times to reset the positions of my cubes. Here it is. Now for each axis we have to put a condition to be able to differentiate between the row in the middle and each of the 2 sides. So to this axis variable, let us just add some specifiers. So instead of X we will use right, left, and mid X. For Y we are going to use top, bottom, and mid Y, and for Z we are going to use front, back, and mid Z. So we will create a button for each one of those conditions. Let me get back my type properties window, and here I will duplicate those 3 buttons here. So I will hit 2 times D to get 9 buttons in total, and then I will begin editing their callback script. So for the first one I'm going to call it rotate right. For the second one, I'm going to call it rotate left. For the third, I'm going to call it rotate mid X. Rotate mid X. Then let me change their code. So here, instead of using X, I will use right. Then instead of using Y, I'm going to use left. And instead of using Z, I'm going to use mid-X. Let me stop the video here and do the same for the remaining buttons, but instead of using right, left, mid-X, I'm going to use, of course, top, bottom, mid-Y, and front, back, mid-Z. Let me do that and I will get back. Okay, so now I've done this manipulation to all of my 9 buttons. You can see the code here, mid-Z, front, etc. I did it for all the 9 buttons. And I hit apply, and here you can see the buttons in my parameter editor, but they are all in one column. So let me just use this option here, which is horizontally join to next parameter, to put 3 buttons per line. So for this one I'll do horizontally join, for the next one also, and let me show you what that does. So I'll hit on apply here, and you can see that now I have 3 buttons on the first line, and I will just skip this rotate mid X to rotate top, and I'll do horizontally join next parameter, and then I'll do it for this one and for those 2 also, and then I'll hit apply, and you can see that now I have 3 rows of buttons. Now let us edit our code to account for this change in our buttons. Let us go to our scripts tab. Now inside of those conditions we know that X became right, left, and mid X, Y became top, bottom, and mid Y, and Z became front, back, and mid Z. So let us replace these conditions with the corresponding new ones. So I will put here if axis equal right, or axis equals left, or axis equals mid X, we are going to rotate around the x-axis. I'll do the same for the y. So if axis equals top, or axis equals bottom, or axis equals mid y, I'm gonna rotate around the y-axis. The same goes for z. So if axis equals front, or axis equals back, or axis equals mid z, I'm gonna rotate around the z-axis. Let us hit apply and try our buttons to see if they are working. So let us click on rotate right, our cube is working. Let us click on rotate bottom, our cube is working also, and rotate mid z, and it's also working. So now that we've got this code working, we have to write all the conditions that will make the decision about which small cubes belong to which face. The idea behind those conditions is that we will check the position of the center of each small cube relative to the position of the Rubik's Cube center. And then according to its relative position, we can know to which face it belongs. So let us begin by retrieving the coordinates of the center of our Rubik's Cube. Back to our type properties. Let me here declare a variable containing the center of my Rubik's Cube. So I will do cube center equals who.node, and here, as we did up here, I will do Rubik's instance.path, and then I will add to it center pause. If you recall, I called the null of the center of my Rubik's Cube center pause. So here I will add center pause. I'll close my apostrophe and my parentheses. And then for this cube center, I will retrieve its world transform. So I will do cube center xform equals cube center dot world transform. Now cube center xform is a matrix, and what we need from this matrix is the translation values, which are located at the positions 3, 0, 3, 1, and 3, 2. So let us get that, and I will call my x and y and z of my cube center trans x, and I will make it equal to cube center xform, and then here I will use a function that will retrieve a value from a position in the matrix for me, which is the at function. So I will do dot at, and I will give it the position 3, 0. And then I will do the same for the y and z. So I will copy this line and I will paste it 2 times, and then I will call this cube center trans y and cube center trans z, and here I will give it 1 instead of 0, and here 2 instead of 0. Now we have retrieved the coordinates of the center of our Rubik's Cube, so let us loop through our small cubes and get their positions. Let us, as usual, begin with a for loop. It's the same for loop used here, so I'll just copy this line and paste it here. Inside this for loop, we are going to retrieve the position of the center of each one of our small cubes. So let me begin just by copying those 2 lines here, and then I will paste them here. But instead of this small cube plus stri, I'm going to use small cube pause plus stri, and this will retrieve the nulls corresponding to my small cubes. Then I will change the name from small cube to small cube pause, and from xform to small cube pause xform, and then we will retrieve the small cube pause world transform. Now that we have the world transform matrix for our nulls, let us get the translate information out of that matrix just the same way we did for the center of our Rubik's Cube. So let me here declare 3 variables. The first one will be small cube translate x equals small cube pause xform dot add 3, 0, and I will copy this line just as I did above, and then I will paste it 2 times, and I will change this x to y and this x to z. Then I will change this 0 to 1 and this 0 to 2. This way, now I have the position of the center of each one of my small cubes and the position of the center of my whole Rubik's Cube. What is left for us to do is to set the conditions that will tell which small cube belongs to which face. Since we know that right, left, and mid-x correspond to the x-axis, so we will use the x coordinates for those. And the same goes for y. We will gonna use the y coordinates for top, bottom, and mid-y, and the same for z with front, back, and mid-z. So let us begin writing those conditions. Here I will hit enter, and inside my for loop, I'm gonna do if axis equals right, I'm gonna do something, then else if axis equals left, I'm gonna do something. Here I forgot an apostrophe, so I'll just put it back here, then I will continue. Let me stop the video here and get the list of those conditions, and I will get back to you when I write all of those. Here are our 9 conditions for our 9 different buttons. Inside each one of those conditions, we are going to check the positions, and then we are going to act depending on that. So let me begin with the first condition, which is if axis equals right. And here inside it, as I said before, we know that right corresponds to the x-axis, so I'm going to use the x coordinates. So here I'm going to add another condition saying if small cube trans x is greater than the cube center trans x, this means that my small cube is on the right side.
but we are gonna give the relative positions some threshold. It's better to do that to prevent float number inaccuracies causing us problems, especially when comparing the middle rows to 0. So here I'm gonna just add some threshold. Let me just open my parenthesis here, and let me declare my threshold before my for loop. I will declare my threshold here saying threshold equals 0.5 for now. Now you may ask, why did I choose 0.5? It's because my cubes here have edges equals to 1. So as I said, one of the reasons is to prevent problems occurring, because when we compare the middle rows to 0, we will have float inaccuracies. So I just took this whole cube here into the equation, and this way I'm going to prevent those problems. And since the edge of my cube is 1, I took 0.5 to the right and 0.5 to the left. So this is why I declared threshold as 0.5. So now if we look at our condition here, we are basically saying if axis equal right, then if small cube translate x is greater than the cube center translate x plus threshold, then we are sure that this small cube, the small cube corresponding to this small cube trans x, is on the right side. Now that we are sure of that, we want to rotate our small cube. So let me just put a colon here, and now inside those two conditions, I'm gonna rotate my small cube. If we look up in our code, you can see that the code rotating our cube is those 5 lines here. To easen out things, let me get my rotation code into a separate function that will be called rotate small cube. So let me just cut this code from here, and then I will define a new function. I will say def rotate small cube, and I will paste my code inside it. Now we have 2 tabs here, so I will just decrease the indent a little bit. Of course, there are some modifications we are going to do on this code to be able to make it work, but for now I will leave it like this, and I will take my rotate small cube function and I will call it inside the conditions we set here. Now what this rotate small cube needs to know to function correctly is the small cube node it needs to rotate, and then the rotation value, and of course the x form. But since the x form here we are not using it inside this code, I'm just gonna cut it from here and paste it directly inside my rotate small cube function. I will decrease its indent a little bit, and then we have this x form here functioning. So what we will need to give to this function in order to function correctly is this rotation value and the small cube for now. And for later on we are going to use the Rubik's instance. I will talk about it when we get to that. So for now, just let me give here small cube and rotation. And then when we call our function up here inside this condition, we are going to give it, of course, the small cube and the rotation. The rotation is calculated here, so it's okay. We can just give the rotation to our function here. And then before this rotation, we are going to give it the small cube. So let me just copy this line from here, and I will paste it here, because as you remember, this line gives me the null. So this line will give me my small cube, and then for my rotate small cube, I will give it also my small cube. So what we did basically is that, let us assume you clicked on the rotate right button. Whenever you click on the rotate right button, this for loop will take place, and then for each iteration we are gonna check if the button you clicked is the rotate right button, and if it is, we are gonna check for every small cube if it's on the right side. So if it's on the right side, we are gonna rotate it. This is the whole idea behind these conditions. So now let us do the same for the remaining 8 conditions. And you shouldn't worry about which axis we are rotating around, because here whenever we say if axis equals right, we are using rotation. Remember that above, if axis equals right, we are rotating around the x-axis. So the rotation is set correctly, and here we are just using it to tell our rotate small cube to rotate around the x-axis, to rotate our small cube around the x-axis. Let us go and do the same for the remaining 8 conditions. So let me copy these 2 lines of code here, And then for the left, I will say if small cube is less than cube center translate x minus threshold, this will tell me that my cube is on the left side. Let me in fact show you that in the viewport. Let me just look here and hit W. Look at our cubes. Now this condition, for example, if axis equals left, then you want to rotate the left side. Let me just rotate this one 80 degrees. The left side is on our left side now. We are checking for every small cube. Let us assume we took this small cube. If the x coordinate of the center of this small cube is less than the x of the center of our Rubik's Cube minus threshold, which is here 0.5, so we are checking if the x coordinate of the center of the small cube is smaller than the x coordinate of this line here, and in fact it is. So you can see that those conditions are telling my code which cubes belong to which faces. Now let me continue writing similar conditions for the other axis conditions, and I will stop the video and I will get back when I write all of them. Okay, so I filled in all the conditions. It's the same for y and z as we did for the x. So here the same explanation is applicable if small cube trans y greater than cube center trans y plus threshold, just as I told you for x, it's applicable for y and applicable for z also. The only difference is that, let us take a look here in our viewport. Now when we want to check for the middle rows, in fact let us say I want to check for this small cube here across the x-axis. I want to check if this small cube's x coordinate is equal to the x coordinate of the center of my Rubik's Cube. But since, as I told you, there is some float inaccuracies, we are going to test if the x coordinate of the small cube here is between this line and this line. So this is why here in the condition, let me get back my type properties, here in the condition you can see that I'm testing the translate x of my small cube if it is smaller than the line on the right side, which is cube center trans x plus threshold, and if it's greater than the line on the left, which is cube center trans x minus threshold. Those two lines here. This is the cube center trans x minus threshold, and this is the cube center x plus threshold. Because if you remember, I told you before, the edge of this cube is 1 and the threshold is 0.5. So this is it for our conditions and our code for this part. I hope I didn't do any typo. So let me hit apply, minimize this, and let us try our buttons. Let me hit W here, and let me try, for example, rotate right. We've got an error here. Let me check the code out. I'll just get back my type properties. And apparently here I forgot to give a slash. So I'll hit apply again, and then I will try my rotate right button one more time. And here you can see that my rotate side of my Rubik's Cube is rotating. And let me rotate top, and you can see that the top is rotating, and so forth and so on. Rotate back, rotate bottom, rotate mid X. Apparently the rotate mid X, rotate mid Y, rotate mid Z are not working. So let me just check the code one more time. I'll get my type properties window. Let me take a look at this condition here. And here's the problem. Here we have small cube trans X with a capital T, and if you look before, we have it with a non-capital T. I will change the T from capital to non-capital in the 3 mid conditions. So I'll change it here also, and then I will get to the trans Z, and I will type T here, and I will hit apply. And now let us try rotating our mid rows to see if that works. And here you go, everything is working correctly. And now you can begin playing with your Rubik's Cube. Everything is working correctly. Let us in the next part do some finishing touches to enable our code to work even if the Rubik's Cube is rotated or even scaled. So let us move on to the next part. Now that we have our buttons working and we can rotate the faces of our cube, let us solve some issues that prevents our rig from working in every situation. The first problem we're gonna tackle is the scaling problem. Let us try, for example, scaling down our cube. So I'll select it, and here I will just take the scale down from 1 to, let us say, 0.2. And then I will try playing a little bit with my buttons. Let me get a little bit closer. And here, if I click on my rotate right, you can see that it's not working.
rotate top is not working, rotate back, nothing is working. But if I click on any button of my mid buttons here, it will work. But you can see it's rotating all of my cube. Let me hit Ctrl Z a few times here. Why is that happening? Let me show you why with this diagram. This diagram may also help you understand the idea behind the threshold if you didn't get it yet. If you remember the conditions we wrote, here we are considering the x-axis conditions, so right, left, and mid-x. And if you take B here, which belongs to the right face, xb is greater than the x of this line, which is x center plus threshold. Same for A, which belongs to the left face, and xa is smaller than x center minus threshold. The last one is mid-x, which in this diagram corresponds to this cube here, and you can see that its x is between x center plus threshold and x center minus threshold. Now, what is causing our problem? Let me add something to my image here. If you consider one of our conditions, let us say the right side condition, you can see that now the x of b is much smaller because we scaled down our cube, so now it is between x center plus threshold and x center minus threshold. In other words, it belongs to mid-x. Same goes for the left side and the other faces as well. Solving that is not that difficult. You can do it manually by modifying your threshold, but this won't be a good solution, especially if you are animating the scale of your Rubik's Cube. A better solution is by taking the scale parameter into the equation, simply by multiplying our threshold with it. So let me get back to Houdini, and here, since we will always scale our cube uniformly, I will just copy this parameter here, which is scale x, and paste it into scale y and scale z. So now whenever I change my scale x, it will change all the three values for me. If I show values here, you can see them. So let me get it back to 0.2 just to get the same example. And now let me include this scale value into my code. So let me get my type properties window, and here I will go to my scripts tab, and then I will just multiply my threshold value with the scale x value of my Rubik's instance node. So here, for my threshold, I will just add multiplied by, and I will copy this Rubik's instance variable from here. I'll paste it down here, and then I will type dot parm to tell it I want to take the scale x, so sx, and then dot eval. That's all we need to do to solve this problem. So now if I click on apply and then I try again my buttons, now they should work correctly. So if I do rotate right, you can see that now it's working. Rotate top, it's working. Back, it's working. Mid Y, it's working. Everything is working correctly. So now our scale problem is solved. Let us next tackle our rotate problem. The only problem we've got left is the rotation problem. Let me show you what the problem is, and then we will proceed to solve it. So let me just get the scale of my cube back to 1, and let me just zoom out a little here, and then I will just rotate my cube a little bit, let us say like that, and I will try my buttons. So now if I click, for example, on rotate top, you can see that all of my cube is messed up, and this is because in our conditions we are using the world coordinates. So whenever we rotate our cube, our conditions won't work correctly anymore, so our buttons won't work correctly. The solution for that is simple. Before performing our conditions and doing our face rotations, we will reset the rotations of our Rubik's Cube, and then we will do our conditions and rotations, and then we will get back the rotations of the Rubik's Cube to where they were before. So let me get my type properties. And here, as I said, before doing anything, I'm gonna reset the rotations of my Rubik's Cube, and I'm gonna save the current rotation values in some temporary variables to be able to use them later to restore the position of my cube. So here on top, I'm gonna begin by declaring three variables. The first one, I'm gonna call it whole cube rotation x, and it will be equal to the Rubik's Cube instance dot parm, and I will tell it to read the rotate x with rx dot eval, and I will do the same to read the y and the z values. So I'll paste this line 2 times, don't forget the tabs here, and then call this whole cube rotation y and whole cube rotation z, and here we have to change rx
to Ry, then Rx to Rz. This way, we saved the current rotation values so we can use them later, and after that, we are going to reset the rotations of our Rubik's Cube to 0. So to do that, let me click enter here, and then I will declare a tuple variable. So here I will use whole cube rot tuple, and it will be equal to Rubik's Cube instance.parm tuple, and I will tell it to take the rotations, so I will give it R here, and then I will set the rotation values to 0. So I will do whole cube rot tuple dot set, and I will give it 0, 0, 0. Then at the end of our conditions and our face rotations code, I'm gonna reset the rotations to what they were before we reset them. So here I'm gonna use the same tuple variable we used above, so I'll just copy it one more time. I'll copy this whole line and I will paste it here. And then for the values, we are gonna use the values we saved up here. So I'm gonna copy this value, I'll put it here instead of 0, and I will do the same for the second value, but I will replace the x with y, and the same goes for the third value, but I will replace the x with z. And I will hit apply, and now let us try. First of all, let us hit Ctrl Z to get our cube to where it was, and then let me try rotate top one more time. And here you can see that it's working correctly. In fact, the thing is happening very fast, so you cannot see it, but it's happening. Whenever you click on the button, our cube rotations are reset to 0, our face is rotated, and then it gets back to where it was before. So all this is happening very fast, you cannot see it, but this solved our problem, and now we have our buttons functioning under any conditions. If it's scaled, if it's rotated, if it's translated, our buttons are functioning correctly. So let us in the next part add a button to set keys on our Rubik's Cube to be able to animate it. Let me here begin with an important remark that I didn't mention before. First of all, let me install the digital asset we've got until now. So let me go to my file menu, install digital asset library, and then I'll make it point to our Rubik's Cube.otl, and I'll hit accept twice. Then let me create a Rubik's Cube node. Now, if I try to click on any one of my buttons, let me click on this one for example, I will get an error, which is normal, because if you remember, the digital asset by default is locked, and what our button is trying to do is to modify parameters inside. So keep in mind that whenever you need parameters inside your digital asset modified, you need to promote them up to the digital asset itself. The rotation parameters of our small cubes are the ones we are trying to modify inside with our buttons. So let us promote them up to our digital asset node. We can do that using many methods. One of the most simple ones is by going to the type properties window. So let me open it here and let me get rid of this error. Then let me go to my parameters tab. Here, let me create two folders to create two new tabs, one for my buttons and one for the parameters I will be promoting. So I will call this one buttons, and for the second one, I'm gonna call it rotations. This is it. So let me take those buttons, I'll select all of them, and I will drag and drop them inside my buttons folder. And now let me just show you what that does. I'll hit apply and unlock and save. And here you can see that my buttons now have their own tab here. So the rotations tab is still empty, and the transform and the subnet are still the same, and my buttons are now inside their own tab. So for the rotation parameters, as we said, we are going to promote the rotations of our small cubes to the digital asset. So to do that, I will go to this From Nodes tab here, and I will expand my Rubik's Cube 1 node, then I'll expand my small cube 1, transform, and I will drag and drop this rotate parameter from here to my rotations folder. I will put it here, and I will hit apply to show you what that does. Now let me go back to my parameters editor, and here under my rotations, now you can see small cube 1 rotate, and if I go inside my digital asset and I go to my small cube 1, it's the first one here, you can see now that its rotates have now ch functions in them, and they are linked to my digital asset. Let me go back up and back to my type properties. Let me stop the video here and get all my rotate parameters under my rotations folder, and I'll get back when I do that. Okay, here it is. I added all of my small cubes rotations to the rotations folder here. Let me hit apply, and now if I get inside my digital asset, you can see that all of my nodes now have the ch functions in them. So let us, for example, say I take small cube 1, I go up one level, and here I will put in its rotate x 90 degrees, for example. So I'll put here 90, and if I get inside again, I'll click on rotate, and you can see the 90 got in here. But don't forget that in our code, the parameters we are modifying are those rotation values in here that now are driven by the parameters up on my digital asset node. So let us modify our code a little bit, making it modify the parameters on our digital asset itself and getting rid of the error. So let me go up, I will get this back to 0, and I will get back my type properties. Then I will go to the scripts tab. The only thing we are going to change here is, let me get down a little bit to my rotate small cube function. Instead of setting the rotation values on my small cube parm rx, I want to set it on its equivalent on the digital asset itself. Its equivalent will be the Rubik's Cube instance dot parm, and then if we look at the parameters here, let me put my mouse a little bit here, and you can see small cube 1 rx, small cube 1 ry, small cube 1 rz. So instead of this, I'm gonna replace it. Let me just delete this line here, and I'm gonna replace it with Rubik's instance dot parm, and now the parameter is the same name of my small cube, adding to it underscore r. So I will do dot parm, and here I'm gonna use this small cube node. So I will take small cube, and I will get its name. So I'll put small cube dot name, and then, as I said, the name of the variable, if you look here, is the name of my small cube, and we add to it underscore rx, underscore ry, and underscore rz. So here I took the small cube name, and I will add to it plus underscore rx. I will close my parenthesis, and then set rotation the same value we had before. I will do the same for my ry and rz. So let me just copy this part here, and then let me delete this line. I'll paste it, and I will change this rx to ry. So I'll do the same for z. I'll paste my line here, and I'll replace my x with z. Now all my code is good to go, except that inside the rotate small cube function, we don't have the Rubik's instance variable, so I have to pass it through its parameters here. So I'll just write Rubik's instance, comma, and whenever I call my rotate small cube function, I want to give it the Rubik's Cube instance. So I'll just copy this and paste it inside all the calls of my rotate function. So I'm pasting it inside all of the calls to my function. Those are all of them. And then let me hit apply and try out our buttons. Let me go to buttons, and now I'll do rotate right, and it's working correctly. Now if you go to the rotations tab, let me scroll down a little bit, you can see that some values got in here. Let me use another button, rotate top, rotate bottom, rotate back, rotate mid Y, mid Z. Everything is working correctly, and here you can see different values are set for you inside those parameters, and those values are driving the rotation values of my small cubes. Let me hit Ctrl Z a few times to get my cube to its initial state. And now that we've solved this small issue, let us move on and create a set key button that will set keys, allowing us to animate our cube. So to my type properties again, parameters, and here I'll go to by type. I'll create a button. Let me just go up a little bit here. I will create a button at the end, and its name will be set key. Its label will be set key, and then we will gonna make it call a function called set key inside our code. We didn't create that function yet, but let me just copy this call script code from here, and then I will paste it for my set key button. In fact, my set key button got outside of my buttons, so I'll just drag it and drop it here one more time. And instead of this rotate function, I'm gonna just make it call set key function. We do not need the axis variable, but still we need the Rubik's Cube instance, so I will leave this instance here, and I will take off the axis variable. So I'll hit apply, and now my button is created here. Now we are going to create the set key function in our code to enable our button to set keys on our rotation values. So let me go to my scripts tab, and here I will go to the bottom. I'll hit enter, and then I'll type def set key Rubik's instance colon, and here I will write the code that will set the keys on these rotation values on my digital asset here, so we will get an animated Rubik's Cube. The first thing I want to begin with is that I want to iterate through all of these lines here, so I'm going to begin with a for loop. So let me write for I in range 127, because I have 26 lines, colon. The first thing I want to do inside this for loop is that I want to autoscope my parameters, and I want to set their lock to false if any exists. So let me begin by declaring a tuple variable for each one of my parameters. Let me begin writing parm tuple equals Rubik's instance dot parm tuple, and here I will specify small underscore cube underscore, and then to loop through all of the parameters I will add to it stri, and then if you go here you can see that it's underscore rx underscore ry underscore rz, so here I have to add at the end underscore r for it to work correctly. Great, now let me set autoscope for my parameters. So here I will do parm tuple dot set autoscope, and then I will set the three of them to true. So true, true, and true. And then, as I said, I want to make sure they are not locked, so I'll do parm dot tuple dot lock, and I will set the lock to false. So false, false, and false one third time, and this is it for those two. Now what's left inside this function is to set the keys on my values. So the first thing I want to do is I want to get the rotation values. So let me begin by writing rot equals parm underscore tuple. Now I see that I've done a small error here, so let me just replace this dot with an underscore, and let me continue here. Rot equals parm underscore tuple dot eval, and now I've got my rotation values inside this rot variable here. So let me now set a key on the rx. So I will declare a keyframe variable. I will call it rot underscore keyframe, and I will make it equals who dot keyframe. Make sure the k is capital, and then open close parentheses and hit enter. Now that we have our keyframe variable, we are going to set its value. To set its value, it's very simple. So I'll do just rot underscore keyframe dot set value, and then I will give it the x rotation value, which we read here inside this variable. So it will be rot square bracket 0 square bracket and close the parenthesis. Then after setting its value, we are going to tell it how do we want the curve to interpolate. So in this case, since we are doing multiple rotations around multiple axes, the best way to interpolate between our keys is to use quaternions. So to tell our curves to use quaternions, we are going to do the following. I will do rot underscore keyframe dot set expression, and here inside my set expression I'm going to tell it you use q linear. I will open close parentheses, and then I will tell it that the language of this expression is EdgeScript. So I will put who.expr language with a capital L dot EdgeScript. This is it. And the last thing we are going to do is we are going to set our keyframe. To do that, we will write parm underscore tuple. It's the same variable we declared up here. And since we want to set a keyframe on the X, we will tell it here square bracket 0 square bracket dot set keyframe with a capital K, and we are going to give it the keyframe we had just created, which is rot keyframe. So I'm going to paste it here, and this way we set a key on our X value. Let us do the same for our Y and Z values. All that's left to do is to copy those 4 lines here, and then we are going to paste them 2 times, and we are going to change this 0 here from 0 to 1, and this one also, and the second one also we will change it to 2 for Z, and we'll change this also to 2 for Z. Then we will hit apply, and this should do it for now. Let us just do a test. If we go to our buttons here and click on set key and go to our rotations, we see that it didn't work. Let me get back my type properties to check for the problem. And here, if I go to my parameters tab, I can see that for my set key, I forgot to set the script language to Python. I will just change it to Python. I'll hit apply again, and now I'm gonna do another test. So I'll hit set key. We've got a small error here. Let us check our script for the problem. So if I get here, I'll look down a little bit. Apparently here, instead of a comma, I put a dot. So let me just replace it with a comma between the 1 and the 27. I'll hit apply a second time, and now I will hit set key. We do not have any errors. And if I go to my rotations tab, now you can see that all of the fields are green, and that means that there are keys set on them. Let us now try to animate our Rubik's since we have those keys set. So let me just go to my frame 24, for example. I will go to my buttons. I will rotate, let us say right. I will set a key. You can see here the green tick in my timeline. I will go to 48. I will rotate top. I will set a key. I will go to 72. I will rotate mid Y, let us say. I will set a key. And then let us scrub through our timeline. And you can see now that our Rubik's is now animated. Everything's working correctly. So let us in the next part add the ability for the user to use a custom geometry.
Like always, install your digital asset and create a node of it. Let us now give the possibility to the user to be able to replace the small cubes with a geometry of his own. Let me do that for one of our small cubes to show you how. Don't forget to allow editing of contents before getting inside. Here I will dive inside my small cube 1. Let us begin by creating a switch node to be able to switch between the default geometry, which is this line here, and the user custom geometry, which we will get using an object merge node. So let me begin by creating the switch node, and then after that let me create an object merge node. So here are my nodes. I'll connect this one and then this one here. So now we have the possibility to switch between our default geometry here, which is our default box, and a custom geometry which we can put inside this object merge. There is a very small issue that we are going to tackle here before moving on. Let us try and create a sphere, for example. So I'll just go up here, I'll create a sphere, and then I will make the scale of this sphere 0.5 since the scale of my cubes is 1, and then I'll go inside my Rubik's here, and here I will make this object merge node point to my sphere. So I will go up here and I will choose my sphere object. Let me make this object merge visible and hit W here, and let me hide other objects. And here you can see that my sphere is rescaled to 1. The problem here is that the transform is set into specified object. So I will just change it from into specified object to into this object, and you can see now that the scale of my sphere is set correctly. The problem I wanted to point here is that now our sphere is not at the same place as our replaced small cube. Let me just make this switch visible, and then I will go up and let me ghost other objects. And here you can see that my cube disappeared from here, but the sphere is still at the center. It's not placed at the place where I want it to be, which is at the place of the small cube that disappeared. So either you leave it to the user to position it by going up to my sphere, for example, and then I can move it here and then move it there. And let me just make this invisible so you can see the one we merged into our Rubik's. Here it is. So now we can see that we moved it a little bit. Let me hit Ctrl Z here because it's not the best way to go, of course. Instead, let us do something better by positioning it ourselves. Let me get back into my digital asset and inside my small cube 1. And here, after my object merge, I will just create an XForm node. So I'll hit Tab and I will type transform, and I will add an XForm node here. Now let us take the position of our box and set it into this transform node. So I will go to my box here, I will copy the center parameter, and then I'll go to my XForm and I will paste it into the translate as a relative reference. And now you can see that the sphere jumped to the correct position. I'll hit W here, and if I use this switch to switch between the two of them, so 1 will give me the cube and 0 will give me the sphere, and both of them are at the same position. We have to drive the switch in a way that whenever a user plugs a geometry into this object merge, the switch chooses it, and whenever the field is empty, it will choose the default box. So I will go up to my object merge here, and inside this object parameter, I'll just copy parameter here, and then I will paste it into my select input as a relative reference. We do not need that as it is. In fact, we need the string from this parameter, so instead of using ch, we are going to use chs, and then we need to check if this string is empty or not, so we will use the expression str match. Let me write it here. I'll write str match, and this way I will compare the result of this chs function, let me go to the end here, to an empty string. So I will add comma, and I will add 2 apostrophes, and I'll close my parenthesis. So this way I'm comparing the result of this chs function here, which gives me the string inside this parameter, to an empty string. If this function returns 1, then my string is empty, and if it returns 0, then my string has something in it. Let me hit enter. Everything seems to work correctly. So now if I go to my object merge, and instead of this entry here, I will just delete it and hit enter, and you can see that directly it switches to the default geometry, and whenever I put something in here, so let me just get back my sphere, it will switch to it. The last step is to promote this object merge up to our digital asset node. So let me get my type properties here, and then under parameters, let me create a new tab for those. I'll just call it custom geometry, and inside this tab I'm gonna go to the from nodes tab, and here I'm gonna choose small cube 1, object merge 1, and then under number of objects I'm gonna choose obj path 1. I will drag it and drop it here. I will hit apply, and here you go. Here we have obj sphere object 1, and if we make this entry empty, it will switch back to the default cube, and then if we point to our sphere, it will switch back to our sphere. A nice thing to add here also is to add a toggle button to show hide the cube you are working on. This way you can make it easier for the user to know which cube he is replacing. To do what we've done for all the other nodes, you can automate that the same way we did before with Python. I will leave that to you to do as an exercise. Let me get custom geometry working for all of my nodes behind the scenes. I will stop the video and get back when it's done. Here you go, we created a custom geometry slot for every one of my cubes. You can see them here. Let me also show you how to create the show hide button, because it has some interesting tip in it I want to show you. Let me go to my type properties window, and here let me go a little bit down, and I will choose a toggle, and then I will take this toggle and I will put it under my custom geo 1. I will do a show hide button for my first small cube. So for the name I'm gonna say show hide 1, and for the label I will also say show hide 1. I'll hit apply, and here you can see it. Now let us create its functionality. So here in the callback script, as usual, let me just go to any one of my other buttons here. I'll just copy this line, and then I'm gonna paste it for my show hide here. But instead of the rotate function, I'm gonna call a function called show hide. Then I will change the script language to Python, and let me take a look at the parameters of this show hide function. In fact, we do not need this axis here, so I'll take it off. We need the Rubik's Cube instance, so I will leave it, and we also need to know on which small cube to act. I'm gonna give it another parameter here saying small underscore cube underscore 1, and I'm passing it as a string by using those apostrophes here. And this is because if you go inside my node, you can see that my first cube is called small cube 1, so I'm just passing it here. And the third parameter we need is the state of this show hide toggle. So if it's turned on, we want to show our geometry, and if it's turned off, we want to hide our geometry. Now to get the value inside the button, the toggle, the field, or whatever triggered the callback script, it's fairly easy. Let me type comma here, and then I will use the same kw args, but this time, instead of using node, I'm gonna use parm. Don't forget to open close the square brackets and the apostrophes, and then I'll type dot eval and open close parentheses. I will hit apply, and now what's left to do is to create the show hide function inside of our code. So let me just copy this part from here. It will ease things out for me inside my code, and I'll go to the bottom, and then I'll create a new function. I will type def, and then I will paste what I copied, and then I will type colon, and then instead of this part here, I'm gonna tell it value, and instead of this part,
I'm gonna put the variable small cube, and instead of this part here, I'm gonna use Rubik's instance. Now the code of this function is fairly simple. Let me just go here and type who underscore small cube equals who.node Rubik's instance dot path, and we will add to that our small cube variable, and we will close our parenthesis, and then all we have to do is use this variable who underscore small underscore cube and set its display parameter. So I will do dot parm, and the parameter is display, and then I'm gonna set its value to value, which is the value we are reading when we call our function. Let me hit apply, and now it still doesn't work. So if I go up and use this, it won't work. The problem is that if we go to our small cube 1 node here, under the render tab here, we have to turn on the display parameter for our code to take effect. So now if I go up and now I use the show hide, you can see that now it's working and my cube is disappearing and appearing. So let me stop the video here and add show hide buttons for all of my cubes, and then I will get back. Here you go. Now I've created a show hide button for every one of my small cubes. So now it's a lot easier for the user to know each slot replaces which cube. So for example, if I use this show hide button here, I directly know that this slot here replaces this small cube. Now that we've changed a lot of things inside our digital asset, don't forget to right click and save operator type. Let us next do some finishing touches on our rotation buttons and create a reset button. Let us create a reset button so we can easily reset our cube to its initial position. Basically, what we want to do is to set all these values here under the rotations tab to 0. Let me begin by creating a reset button. So I will get my type properties window, and here I will just add a button to my buttons tab. So I'll go a little bit up and I will bring a button here. Then its name will be reset, its label will be reset, and then I will copy the function from here, just like I did before, nothing fancy, and I will paste it in the callback script of this reset button. Instead of set key, we're gonna call the function reset, and it will need the instance of the Rubik's Cube, so I will leave this kwargs node here. I'll hit apply, and then I will go to my scripts tab, and here I will create my reset function. So I will type def reset, and as we said, we will gonna need the Rubik's instance. Then what this function will do is it will loop through all of those parameters here and set them to 0. So I will begin with a for loop for I in range 127 Rubik's instance dot parm tuple, and then if we look here we can see that the parameters are called small underscore cube underscore 1 underscore rx, and the same for ry and rz. So to get our tuple, we have to give it small underscore cube underscore 1 underscore r, and since we are looping through all of the parameters, instead of 1, we are gonna use the stri. So here inside my parm tuple, I'm gonna give it small underscore cube underscore, and here I'm gonna add to it stri, and then I will add underscore r. Now I've got my tuple, all is left to do is to set all of its values to 0. So I'm gonna do dot set, and here I'm gonna give it 0, 0, and 0. This is it for my reset function. Let us try it to see if it works. So I will go here under my buttons, and then I will just do some rotations randomly, and then I'll click on my reset button. It didn't work, and that's because I didn't change my script language. So I'm gonna go to my parameters here, and I'm gonna change this from HScript to Python. I'll hit apply again, and now I'll hit reset, and you can see that my cube got back to its initial position. One other thing I want to add to my code to make it more interesting is an angle variable. So let me go into my code again. By looking at those build rotate functions, one question comes into my mind. What if the user needed to rotate -90, for example, or 45, or any other value? With what we have here, it is not possible, because we are always rotating with 90 degrees value. You can see it here, 90, 0, 0, 0, 90, 0, and 0, 0, 90. So let us replace these 90s with a variable
I will call it angle. So I'll put, instead of this 90 here, I'm just gonna put angle, and for the second one I will do the same, and the third one also. And I will pass it to my function the moment I call it. So I will put it in here also. After my axis, I'll just put the angle variable. For my existing buttons, I have to specify the angle they should rotate. So let me go to my parameters tab, and for all of my buttons, now I should give them an angle. Let us give all of them 90 degrees for now. So I'll just fill in 90 for all of them. I'll stop the video and get back when I do that. So I gave 90 degrees for all of my existing buttons. Let me add 2 other buttons here, just to give them different values. Let me make this one rotate my right face minus 90 degrees, for example. So I will copy the same code we have here, but instead of 90, I will gonna give it minus 90 instead. And then I will just copy rotate right. And here I will call it rotate right minus 90. And here also I will call it minus 90. I will hit apply just to test this button if it's working. And here, let me just rotate right. It will rotate my right side 90 degrees. And if my code is working correctly, when I press this button, my Rubik's should get to its initial state. So I will press this, and it's working correctly. Now you can see that this is rotating 90 degrees, this is rotating minus 90 degrees. Now with the angle variable added, you can make your buttons rotate any values you want. And now it's up to you to construct the interface you see fit for your situation. Let me show you the final interface I've built. You can see here I have for every face, if you look here, I have right, left, top, bottom, etc., mid X, mid Y, mid Z. I have for every face 2 plus minus 90 degrees buttons, 2 plus minus 180 degrees buttons, and 1 custom rotate button. Let us create a simple animation before ending this tutorial. So I will just get a little bit closer, and I will set a key. Then I will go to my frame 24. I'll just rotate 90 here. I will set a key. I'll go to 48. I will rotate plus 180. I will set a key. I will go to 72. I will rotate mid Z minus 90. I will set a key. I will take my whole Rubik's. I will just go to my frame 1. I will go to its transform tab. I will set a key here. I will go to frame 48. I will rotate it a little bit. I will set a key. I will set a key on its scale. I will go to frame 72. I will set another key on its scale, but I will make it a little bit bigger. I'll set a key here. Then I'll go to frame 96. I'm gonna rotate, let us say left plus 90. I will set a key. Then I will set a key on its translate. Then I will go to frame 120. I'll just translate it a little bit like that. And then I will set another key. So this way I'm showing you all the possible combinations. I'm rotating my cube, I'm translating it, I'm scaling it, and at the same time I'm animating my faces. And now if we play our animation, my cube is animating very well and everything's working correctly. This is all I wanted to say through this tutorial. I hope it was useful to you, and see you soon with new videos.